Okay, we're going to do this first question of prep for the calculus question, for prep for the calculus control test. And here we go. It says, using first principles, figure out what the derivative of f of x equals 3x squared minus x is. Well, your first job, before you're given this formula here, f of x plus h minus f of x over h, the limit as h approaches 0, that's the derivative. But we're not going to use it right away. What we're going to figure out is, what is f of x plus h first? So all we do is we take x plus h and we put it into the function. We go 3 times x plus h squared minus x plus h. And then you multiply it out. X plus h squared is x squared plus 2xh plus h squared. Well, then you multiply everything by 3, and it goes into 3x squared plus 6xh plus h squared minus x minus h. Remember, you're subtracting these two things that are added. So there's f of x plus h. But in the formula, it says we're supposed to subtract f of x. Well, f of x is 3x squared minus x. We have to subtract that from the answer we got for f of x plus h. We'll write it all out, and look what happens. 3x squared minus 3x squared is 0. And here we have minus x minus x is minus x plus x. That cancels. So all that's left is the 6xh, the h squared, and the minus h. Well, that's f of x plus h minus f of x. Now you're ready. You're going to write what you just figured that out to be. Instead of f of x plus h minus f of x in the formula, substitute in f of 6xh plus h squared minus h. Then factor out the h, let the h's cancel, and then if you let h approach 0, the derivative will be 6x minus 1, which is good because 2 times 3 is 6x, and then minus x, the derivative is just 1. So there we go. That's how we do the first principles part. The next part is you have to find the derivative of these three things. Well, they're not in the right form. So this x to the squared in the bottom really just goes up to the top and becomes x to the minus 2. And now it's in the right form. So you just have to know that x squared is really x to the minus 2. You have to know that x, the square root of x, is x to the half. Now it's in the right form. Multiply minus 2 times 2 over 4, you get minus 4 over 3. Subtract 1 from minus 2, you get minus 3. There's your answer there. 1 half times you bring it down 1, you get minus 1. Okay, the last question of this section. Determine the equation of the tangent at x equals 2. That's a line pushed up against this cubic curve. What would the equation of that line be at x equals 2? Well, the first thing that might be good to figure out is, what is that point? What's the y-coordinate at that point? If you put 2 into the function, go 2 times 2 cubed minus 3 times 2 plus 5, you'll get 15. So 2 and 15 is the point you're looking for, where you're trying to find the equation of the line that touches right at that point. Well, how do you find the gradient at x equals 2? Because they said find the equation of a line. You need the gradient. You've got the point now, 2 and 15, but you need the gradient. And calculus derivatives are all about gradients. So find the derivative. 2 times 3 times 2 is 6x squared minus 3 there. There's the derivative. And then put 2 in there. Put 2 into the derivative formula. You'll get the gradient when x is 2. And it turns out the gradient is 21. Well, now you've got everything to do the line. The gradient is 21. The point, the x value of the point is 2. The y value is 15. Just put those things into the point gradient formula for a line. And there's your answer. 21 times x is 21x. 21 times minus 2 is minus 42. We add 15, and I think we get minus 27. There's the equation of the tangent line at x equals 2. And that's the first part of the calculus section that we're going to need for the control test.